So here, students, we are having second lecture on application of derivative. In last lecture, we started with equation of tangents and normals to a curve. Now, let us solve one more question here. The question is, find the equation of tangent and normal to the curve at the point on it. Now see, we are given the equation of curve in parametric form. You can check here, x equals to root t and y equals to t minus 1 by root t. See, the equation of a curve could have been given as y equal to f of x. See, we can be given equation of curve in y equal to f of x form. But they are giving us equation not in y equal to f of x. You can check the earlier lecture. We had the curves given in the form y equal to f of x or f of xy equal to 0. The equation of a curve can be given, listen carefully, the equation of a curve can be given as y equals to f of x, that is with the help of an implicit function, with the help of an explicit function, or f of xy equals to 0 with the help of an implicit function. See, if I'm given a curve like this, if I'm given a curve y equals to x square plus 2x minus 6, if this is the curve, then I will call this curve as what form? This equation of the curve is in explicit form. This represents an explicit function. See, y equal to f of x. But suppose if I'm given a curve which is say x square plus 2xy plus y cube equals to 0. Now this equation of the curve, if I'm given, then I would call this curve in implicit form, because this is f of xy equals to 0. So this is explicit, this is explicit, this is implicit. Okay, here you have x and y both together. But in this question that we have right now with us, in this question we have neither implicit nor explicit. We are given the function with the help of a parameter t, so we will call this as parametric function. So we have a function here. See, either you can, there are two ways of solving this. One is from this parametric equation, you get the equation in explicit form and then go ahead. So see here, I write this as 1, I write this as 1 and this as 2. Now I write from 2, just understand what I'm doing. From 2 we can write. From 2 we can write. See, I can write y equals to, it is t. I can write t as root t square. T is nothing but root t square minus 1 upon root t. Root t square minus 1 upon root t. Now what I'll do, I will use 1 here. So I get y equals to, see, what is root t? Root t is x. So x square minus 1 upon x. Okay, and what am I writing here? I will write that using 1. Using 1. Now what you have? See, you manage to get the equation of the curve in what form? In explicit form. This is explicit form. Y equal to f of x. After this, you know the process. The procedure is you will go for the dy by dx. You will find dy by dx at the given point. What is the point here? The point is t equals to 4. So the point is t equals to 4. But then see, if you have t equals to 4, since you have written the equation in explicit form, there is no t here. So what will happen? That we will have to see. So let us first differentiate y equals to f of x. I write differentiating, I write this as number 3. Differentiating 3 with respect to x. So I get here, therefore, d by dx of y equals to d by dx of x square minus 1 upon x. So I get dy by dx equals to 2x minus d by dx of 1 upon x is minus 1 upon x square. So I get 2x plus 1 upon x square. This is dy by dx. Okay, so students, I got dy by dx. I got dy by dx. What is next step? I have to find dy by dx at the point where the tangent and normals are required. Okay, so dy by dx, here I have as 2x plus 1 upon x square. Now see, in dy by dx, I have 2x plus 1 upon x square. So I need to substitute the value of x, and there is no y as such here. So I need to substitute the value of x where the tangent or the normal is expected to be drawn. So what is that x value? Now see, the point where they need the tangent, they say at that point the t value is 4. So when t is 4, I would calculate what x is. So I write when t equals to 4, when t equals to 4, x equals to square root of 4, that is 2. X equals to square root of 4, that is 2. Okay. Now here I would like to say something. You know, some students have habit of writing, if they're writing root 4, they would write plus minus 2. This is not correct. Please don't do this. You are finding only the square of root. You are finding the root of 4. You are not finding minus of root 4. Please understand, if it is root 4, it is 2. If it is minus of root 4, then it is minus 2. Okay, so never write the square root. If it is only the square root, don't write plus minus. It is only plus that you will write. Okay, so here we have written x value as 2. So when t is 4, what is x? X is root 4, which is 2. Now this x I will substitute here in dy by dx. This is number 4 I write. So the next step I write is therefore dy by dx at x equals to 2. Okay, actually it was t equals to 4, but t equals to 4 is same as x equals to 2. And what is that equal to? That will be, you will substitute, so 2 multiplied by 2 plus 1 by 2 square. Okay, so that is 4 plus 1 upon 4 you get. 4 plus 1 upon 4 you get. Okay, I will not write there. So this is 4 plus 1 upon 4. I got therefore dy by dx at x equals to 2 is 4 plus 1 upon 4. That is equal to 17 by 4 we got. And what is this? It is the slope of tangent at t equals to 4. Slope of tangent at t equals to 4. What will you do next? After you got the slope of tangent, the next you find is the equation of tangent. Okay, so I write equation of tangent at t equals to 4. Now see students, equation of tangent at t equals to 4, but you know that if you want to find the equation of tangent, then you should have the point as x comma y. Suppose you want the tangent to this curve at one point. Okay, you want the tangent to this curve at one point, at some point, and at that point the value of t is 4. The value of t is 4. At that point t is 4. But we do not need the parametric value of that point. What we need is the x comma y value of that point. We want the Cartesian coordinate. So what I will do, this t equals to 4, which I have, I will put this t equals to 4 in parametric equation. You're getting it? I will put t as 4 here. I'll get x coordinate for t4, and I'll put here, I'll get y coordinate of t4. So x coordinate is already operand, which is 2. I'll just have to work for the y coordinate. So this y will be 4 minus 1 upon root 4. See, I'm putting t here. So I write here y equals to t minus 1 upon root t. So y equals to 4 minus 1 upon root 4, which is 2. So I get 8 minus 1. This is 7 by 2. I got y value. What is y value? 7 by 2. I got the value of y as 7 by 2. So understand, students, that when t is 4, the coordinates are 2 comma 7 by 2, x comma y. You want the coordinates of the point in x comma y form. Okay, you want it in x comma y form. So x is 2 and y is 7 by 2. So what I would now say, I would say that I want the coordinates of, I would say that I want the equation of tangent. I would say that I want the equation of tangent at 2 comma 7 by 2. Therefore, equation of tangent at 2 comma 7 by 2 is, y minus y1 equals to m x minus x1. So you have y minus 7 by 2, y1 is 7 by 2, x1 is 2. Okay, so y minus 7 by 2 equals to m is 17 by 4 into x minus 2. Okay, you can multiply throughout by 4. You multiply throughout by 4, you will get 4y minus 14 equals to 17 x minus 2. I'm multiplying throughout by 4. So this becomes 4y. Here 2 cancels, so you get 14, and this is 17. This 4 cancels, you are left only with 17 into x minus 2. So the next step, you will get 4y minus 14 equals to, multiply this 17 inside, 17x minus 34. 17x minus 34. So you get therefore 17x minus 4y, 17x minus 4y minus 20 equals to 0. This is equation of required tangent. Now we want the equation of normal. That is, what you want now is the equation of normal to the curve at the same point where you have the tangent. So this is the equation of normal. See, a normal is perpendicular to the tangent at the same point where the tangent to the curve is. So you have to get the equation of this yellow line. Okay, yellow line. So I will go for the slope first. Slope of normal. I will find out the slope of normal. So here I write slope of normal. I'll write here slope of normal equals to -1 upon slope of tangent. See, the tangent and normal are perpendicular to each other. They are perpendicular to each other. So if you multiply the slope of normal with the slope of tangent, you should get -1. So the slope of tangent, you have 17 over 4. So slope of normal will be -4 over 17. Just negative reciprocal of this. So now since you have -4 upon 17, if you multiply these two, you will get -1. Okay, so I got slope of normal. Now I will write equation of normal. Therefore, equation of normal is y minus y1, you just saw what is y1. Y1 is 7 by 2. Y minus 7 by 2 equals to m. What is m? M is minus 4 by 17. Minus 4 upon 17. X minus x1. What is x1? X1 is 2. So now you multiply throughout by 17. So, okay, no need to multiply 17 because here you have 2. So, okay, so 2y minus 7 upon 2 equals to minus 4 upon 17 x minus 2. Okay. We can go for cross multiplication because we have fractions on either side of the equal to sign. We can go for cross multiplication. So we'll get 34y minus 17 into 7. 119. Okay. So 34y minus 119, and this 2 will multiply here. You get minus 8 times x minus 2. So you have now 34y minus 119 equals to minus 8x plus 16. So you have 8x minus 8x plus 34y and minus 135 equals to 0. This is equation of required normal. This is equation of required normal. You can go ahead and check this. Now we have another question. See here, the second question is find the point on the curve. Find the point on the curve. What is the curve? Y equals to square root of x minus 3, where the tangent is perpendicular to this line. So try understanding what the concept is. The concept goes as there is some curve. See, we do not know what is that curve, so we can draw any curve. It's okay, no problem. There is some curve, and this curve equation they say is y equals to square root of x minus 3. This is the equation of the curve. Now they say there is some line. There is some line which is this. This is the line. 6x plus 3y minus 5 equals to 0. This is line. And this line is say here is the line. Okay, here is the line. Somewhere line. So the equation of the line is 6x plus 3y minus 5 equals to 0. Now here the question is that we need to get the tangent to this curve such that the tangent is perpendicular to this line. I hope you are following. What they're saying get the tangent to the curve such that the tangent is perpendicular to the given line. Now, such a tangent where you would be drawing, you have to get the coordinates of that point. Now, see, understand students that on the curve, on this curve, students, you understand that you have infinite points. You have infinite points on this curve. Okay. There are infinite points on the curve. Now, at every point you can have a tangent, but try understanding that not every tangent you draw to the curve will be perpendicular to this line. Suppose I draw the tangent at this point. I draw the tangent at this point. So is it perpendicular? The answer is no. See, this angle is not 90. This is not 90. It is more than 90. From this side, it is more than 90. Suppose I get a tangent to the curve. I get a tangent to the curve at say this point. this point. See, I'm drawing a line which is touching it. Is this 90 degree? No, it is not 90. Again, you see this angle is lesser than 90. I have to get it in such a way that it is perpendicular. So what I would do, so I go for a tangent here. I go for a tangent, and the tangent is perpendicular. It's 90, it's perpendicular. I go for a tangent, and the tangent is perpendicular to the, it is perpendicular to the line. And students, see what they are asking. They are asking, get the coordinates of that point. Get the coordinates of that point. I have to get the coordinates of this point where you drew the tangent and the tangent was perpendicular to the given line. Okay, so I have to get the coordinates of this point. See, students, I will call this point as h comma k. I will call it as h comma k. So now what is my aim? My aim is to get the coordinates of h and k. Okay, I have to get the coordinates of h and k. So I start solving it. See, what is the first step? The first step is I have to get the value of h and k. Understand? You have to get the value of h and k. Now, if you compare this question with the questions that you solved earlier, you would be thinking that this is totally different question. See here, you will notice that ideas that we are going to work will remain the same. Here they're asking me the coordinates of this point, and I assume the point is h comma k. So I have got now two unknowns, h and k. So if I want to get the value of these two unknowns, I should be working on two equations which involve these unknowns. You know, if you have two unknowns and two equations, you can easily solve to get the values of those. Okay, so see, how do I proceed? It's very easy question. At the same time, it's very interesting question. Okay, so let us start solving. See here, I begin my solution with the given curve. The given curve is y equals to root of x minus 3. I write here differentiating with respect to x. So I get dy by dx as d by dx of root x minus 3, that is 1 upon 2 root x minus 3 into derivative of x minus 3, 1 minus 0. So it is that only. Now, I got dy by dx, but where is this tangent actually drawn? The tangent is at h comma k. You understand? The tangent is at h comma k. So here I write, therefore dy by dx at hk. It is 1 upon 2 root h minus 3. Okay, so this I write it as 1 and this is 2. What is this 2? What is this 2, student? What is this? It is the equation of the said tangent. Said. It is the slope of the said tangent. It is the slope of the tangent at h comma k. Okay, it is the slope of the tangent at h comma k. I write therefore slope of tangent at hk equals to 1 upon 2 root of h minus 3. This is the slope. What I do next is, see, in the next I will write see here I have this line 6x plus 3y minus 5 equals to 0. Let me find out the slope of this line. I write here slope of 6x plus 3y minus 5 equals to 0 is minus a by b, minus 6 by 3. You know, if you have a line in general form, then its slope is minus of a by b. Okay, you know, if a line is in general form ax plus by plus c equals to 0, then the slope of that line is minus a by b. Okay, which you have done in straight lines in 11th standard. This much you should know. So here we got the slope of the line, that is minus 2. Now see students, the slope of this line is minus 2. Which line? This line. The slope of this line is minus 2. The tangent which is in the question, the tangent is perpendicular to this line. So what will happen? What will happen? It has to now, if the tangent is perpendicular to this line, the slope of the tangent should be negative reciprocal of slope of this line. So I will write therefore slope of tangent at h comma k should be equal to negative reciprocal. See, what is reciprocal of this? Minus 1 by 2. What is negative reciprocal of that? 1 by 2. Now see students, you have already found the slope of that tangent. You see this tangent, you have already found the slope of the tangent, and which is this. So you can equate this slope with this slope. So you will write therefore 1 by 2 root of h minus 3 equals to 1 by 2. Okay, this 2 and 2 cancels. This 2 and 2 cancels. So what you will get? You will get therefore root of h minus 3 equals to 1, and h minus 3 is also 1, squaring on both sides. So h equals to 4. What do you got? You got h as 4. Now see students, after getting h, what you will do? Look at this point. You have to get the value of k now. Look at this point. This point is a common point on the tangent and the chord. It is a common point. Sorry. Now this point h comma k lies on the chord. This point h comma k lies on the curve. What does that mean? The coordinates of the point will definitely satisfy the equation of the curve. So here I will write here point h comma k will satisfy equation of curve. Therefore, what does that mean? Where we have x, we can write h. Where we have y, we can write k. So k equals to root of h minus 3. What does that mean? K equals to square root of h. You got 4. 4 minus 3. That is root of 1, which is 1. So now you got h as well as k both. So you got that point, which is the point is 4 comma 1. So you will write the final answer. Therefore, the required point, what the question was? The question was find the point on the curve. You see this? You have found the point on the curve where you draw the tangent, and the tangent is perpendicular to the line. So therefore the required point is 4 comma 1. This is your final answer. I hope you all followed this. Now we have a similar question here, and see what does it say. The question is find the point on the curve. This time the curve is y equals to x cube minus 2x square minus x. Y equals to x cube minus 2x square minus x. Find the points on this curve where the tangents are parallel to this line. Okay, so what would that mean? See, there is or tangent. I will say I'm not solving this problem because this is similar, so you can solve. So think there is a curve like this. And what is the curve? The curve is y equals to x cube minus 2x square minus x. Okay. And then there is a line. There is a line whose equation they give. The line is say this. Okay. Now what they expect from you, they say get the points on this curve. You see this curve? They say get the points on this curve where the tangents would be parallel to this given line. Okay, this 3x minus y plus 1 equal to 0, it is equation of this line. It is equation of this line. Okay, so see, I need to draw a tangent which is parallel to this. I need to have a tangent which is parallel to this. So see, this is one tangent. And then there is one more tangent. What's happening? Both the tangents you drew, both the tangents here, which one? This tangent and this tangent. They are both parallel to the given line. What is the given line? The given line has equation 3x minus y plus 1 equal to 0. So where are these tangents drawn? You need to get the coordinates of that point. So you need to get the coordinates of this point and this point. Okay. Now, students, you would be thinking that how I know that there would be such two tangents? Because when it was the previous question, there was just one tangent which was perpendicular to the given line. How do I know that there would be two tangents parallel to this? See, as a beginner, you might think that you do not know it. As a beginner, you think you do not know that there would be two tangents. Okay, you think there would be just one tangent. So what I'm trying to tell you is, you may not go for the correct diagram. You think that there is just one tangent. Okay, you do not even draw the curve the way I drew, because see, you do not know that how would a cubic equation look like. Okay, you draw only this much. Say you draw only this much. The curve you draw only this much, and then you have your h comma k. Now what you do, you go by the procedure. You have the equation of the curve, you differentiate, you will get dy by dx. You assumed that point to be h comma k. So you will find the slope at h comma k. You will get some slope. This slope has to be equal to the slope of this line. See, you got the slope of the tangent, at h comma k, but this slope is parallel to this given line. Hence, the slope of the tangent should be equal to the slope of this line, which is minus a by b. So minus of 3 upon minus 1, that is equal to 3. So this should be equal to 3. You will get one equation in h and k. Then you will substitute that in the equation of the curve. You will get the value of the required value. Now in this, you will notice, students, that when you solve the problem, automatically on its own, if there are two tangents, then you will get two values of h and two values of k. What I'm trying to tell you is, if there is a possibility of two tangents, you need not worry. Automatically, mathematics will take care of it, and it will give you 2 points. It will give you two h values, and hence you will get two k values. But in beginning, you go by one only. Mathematics will take care of it. Okay. Now, why this happens? This way you can solve this problem. Now, why this happens, I'll tell you. See, There are certain curves. Suppose here I draw a circle. Okay, let me draw a circle here. Let me draw a circle here, and then I ask you, draw tangent to the circle which are parallel to this red line. If I ask you, draw tangent to the circle parallel to the red line, students, automatically there will be two such tangents, not one. You will have two such tangents which are parallel to the red line. You understand? One here and one here. So there are certain curves, which will give the outcome like that. So is this curve. So is this curve. This curve also, there would be two tangents. I hope you are following what I'm trying to say. You solve the way I told you, you will get the required answer. Okay, see this question number 4 now. Find the equation of the tangents to the curve which are parallel to x-axis. So see this curve is, see here, there is certain properties that this curve exhibit. Look at this curve. This curve is a second degree equation. It is a second degree equation in x and y, but it is not homogeneous because you got, see here, you got the power of x as 1, whereas power of x here is 2. It is not homogeneous. It is a second degree equation, but it is not homogeneous. What is a homogeneous second degree equation? If all the terms there will have the xy aggregate power equals to 2, like you have x square plus 2xy plus y square equal to 0. If you had like this, then you say here power is 2, here power is 2, here 1 plus 1, 2. So it's a second degree homogeneous equation, but here it is not. Here what it is? It is only the second degree equation. Okay. We are solving problem number 4. So the other problem I just solved here. Fine. So here we have, students, see, we have a second degree equation here. This second degree equation, I noticed that it has got x square and y square coefficient equal. The coefficient of x square and y square are equal. See, both are 1 plus 1. Further, I noticed that there is no x into y term. There is no xy term. There is no xy term. And whenever such a thing happens, I understand that it is a circle. So remember, students, what is this? It is a circle. Like if you have a linear equation, suppose I write 2x minus 3y plus 7 equal to 0. What you say? This is a straight line. You say it's a straight line? Yes. So as you say that as a straight line, because it is in the form ax plus by plus c equals to 0, you know, students, that such equation is a circle. Now what do they say? They say in the question that find the equation of tangents to this curve which are parallel. Find the equation of tangents to this curve which are parallel to x-axis. So see here, I have here x-axis and I have here y-axis, I have here x-axis, and then I have the circle here. I do not see, I'm not going for that diagram, you know, I'm not bothered about actually drawing the correct diagram. This is only for the representation purpose. I'm drawing y-axis, x-axis, and the circle. This circle is, see, I do not know this circle. I did not find the center. So it may not have the center in the first quadrant, or it may have, I'm not bothered. It is just a rough sketch. So I have the circle here and they say find the equation of tangent to the curve which are parallel to x-axis. So what way those two tangents be? What way those two tangents would be? See, one would be this way, parallel to x-axis, and the other is here parallel to x-axis. You see this? Okay, so you have to get the equation of tangent. Now listen, students, to get the equation of tangent parallel to x-axis, if a tangent is parallel to x-axis, its equation will be in the form y equals to k. Y equals to k. Because it cuts the y-axis at some point. You understand? So y equals to k, that number if you have. So as such, if you get the coordinates of, if you get the y coordinate of any point on the curve, I'm sorry, on the line, on the tangent, if you get the y coordinate of any point on the line, you would get the equation of the required tangent. So see, how do I begin? How do I begin solving this? So here I write the given curve is the given curve the given curve is, it is x square plus y square minus 2x minus 4y minus 2x minus 4y plus 1 equals to 0. I will differentiate this with respect to x. So when I differentiate, see, I get d by dx of this left hand side and d by dx of RHS. So 2x, d by dx of y square is 2y, d by dx of y minus 2 into d by dx of x is 1 minus 4 dy by dx plus derivative of 1 is 0 equal to 0. Now in the next step, I get here, therefore, I divide through it by 2, and from this 2, dy by dx is common. So I get dy by dx common, and I get here 2y, okay, I'll divide later, 2y minus 4, and these two I shifted to left, so minus 2x plus 2x, okay, so I get here, therefore, dy by dx is equal to take minus, so you have 2x, take 2 common, so here you have minus x plus 1. I'm taking 2 common from this, minus x plus 1. On 2 common here, y minus 2. This 2 cancels. So you got minus x plus 1 upon y minus 2. This is dy by dx. Okay, what I do next is I take this point as, see students, I told you, if you do not understand, see, which is not possible, you all know the equation of circle. But in case if anybody says, I do not know the equation of circle, still, you can go by just one tangent, and you did not draw the circle. It's okay, you do not draw the circle, you just draw some curve. Okay, you draw some curve, and the tangent that you draw is parallel to x-axis. See, you can go by this, you draw a curve and then you draw a tangent parallel to x-axis. So what I would do here, I take this coordinates as h comma k, I write here. Okay, let the point, see, if you want to get the equation of the tangent to this curve, definitely there would be some point where the tangent is drawn. I assume that point as h comma k. Now, why is that necessary? It is necessary because you want to get the equation of the tangent. So try to understand that equation of a tangent you would get if you know a point on the tangent. The question they have made very, very, very easy by writing. They have made the question very easy by writing that the line is parallel to x-axis. The tangent is parallel to x-axis. See students, any tangent which is parallel to x-axis will have equation in the form y equals to k. So what is that k? That k is nothing but the y coordinate of a point on the tangent. So that y coordinate you have to get. And that is what I'm planning for. So see here, I got dy by dx. Now what I will do, I write here dy by dx at hk, at h comma k, which is minus k plus 1, I'm sorry, minus h plus 1, x is h. minus h plus 1 upon k minus 2. Okay, what is this? It is slope of tangent to the curve. Slope of tangent to the curve. But what I am given, students, I am given that these tangents are parallel to x-axis. The required tangents are parallel to x-axis. So I will write here, since the required tangents are parallel to x-axis, therefore slope of tangents will be equal to 0. You know, any line which is parallel to x-axis has slope 0. What is slope of x-axis? Slope of x-axis is 0, and the lines parallel to x-axis also have slope 0. What is slope of y-axis? Not defined. Slope of y-axis and the lines parallel to y-axis are not defined. Please copy this much. So the required tangent is parallel to x-axis. We know that the slope of the tangent will be 0, and we have already found the slope of the tangent here. So this can be equated to 0. What I will do next, I will equate this to 0. Therefore, we can write minus h plus 1 upon k minus 2 equals to 0. That means we have here minus h plus 1 equals to 0. This k minus 2 multiplies there. K minus 2 multiplies, you get 0. So you get minus h equals to minus 1. So h equals to 1. You got the value of h. That is the point where you draw the tangent. Its x coordinate is going to be 1. See, this point will have x coordinate as 1. Now I will get the value of k, and that is, for that, what I will write? I will write the point h comma k lies on the curve. You see this? This is the equation of the curve. I will write, since h comma k lies on the curve, therefore hk will satisfy equation of curve. It will satisfy equation of curve. What does that mean? Where I have x, I can write h. Where I have y, I can write k. So h square plus k square minus 2h minus 4k plus 1 equals to 0. Okay, this h value you have already got. H is 1. So you have 1 square 1 plus k square. Minus 2 into 1 is minus 2. Minus 4k plus 1 equals to 0. Now here you have 1 plus 1, 2, minus 2 gone. So you got k square minus 4k is 0. So k is common, k minus 4. K is common. So another bracket, you get k minus 4 is 0. So you got, therefore k equals to 0 or k equals to 4. So you got k 4 and k 0. So those 2 points you got. What are those 2 points? Therefore, the 2 points where the tangents are drawn. Okay, so I can write here. I will write here, therefore, the required tangents are, therefore, the required tangents, okay, are at points. They are at points. The required tangents are at points. See, h comma k. What is h? H is 1 and k you have 0 or 4. So h the points at 1 comma 0 and 1 comma 4. See, h is 1. H is 1, but for h1 you have got two k values. So once you will take 1 comma 0 and the next is 1 comma 4. Now see students, when it is 1 comma 0, now you know it is, see this diagram, as I said, it is not a perfect diagram. It has definitely some mistake in this. See 1 comma 0, this point is having y coordinate 0, so it is 1 comma 0. The tangent is at this point, somewhere here it is 1 comma 0. And the diagram which I have drawn, see, this is okay, but then this point here is definitely not 1 comma 0. This point is on x-axis, 1 comma 0, y coordinate is 0. So this diagram is only for representation purpose. It is not an accurate diagram. And you don't have to worry in exam, even if you draw such a diagram, it's okay because it is understood that you are drawing a diagram just for the reference purpose. So you got the points at 1, 0 and 1, 4. So you write therefore the required tangents are y equals to 0 and y equals to 4. See how y equals to 0 and y equals to 4. If the tangents, it is already said that the tangents are parallel to x-axis. And the equation of lines which are parallel to x-axis, it is in the form y equals to k. So these are 2 points where the tangents are drawn. You understand? So this point, if suppose it is 1 comma 4, so you have the y coordinate of this point as 4. So if y coordinate is 4 here, definitely this point will also have y coordinate 4. The only thing is it is 0 comma 4. Now you understand, equation of this line will be y equals to 4. Now here, as I said, that this is not correct diagram. This point should have been, this circle I would have to shift a bit, so that this tangent which I have here, it is nothing but, it is coinciding with the x-axis, because this point is on x-axis. It should be here, So the equation of x-axis is y equals to 0. It is the same thing that you are doing for both. You're just writing y equals to this number and y equals to this number. Y equals to k. That completes the solution.